Okay, so now that we've talked about a little bit about what logarithms are, and we've talked about the two special logs, log base 10 and log base e, the common log and the natural log, we're not going to return to this relationship between logarithms and exponentials and see how we can actually use it to rewrite equations so that we can actually put it into a format sometimes that we can solve them. So recall, log base b of x means x equals b to the y. In other words, the logarithm is the inverse of the exponential function. The y equals log base b of x, we refer to that as the logarithmic form of the equation. The x equals b to the y, we refer to as the exponential form. And so some of the problems you're going to run into in the homework are going to ask you to rewrite and then possibly solve the resulting equation. So here we're asked to write our equations in exponential form. So we're going to be given an equation to start off with that's in exponential form, and we're going to rewrite it, we're going to start off with an equation in logarithmic form, and we're going to rewrite it in exponential form to be able to solve it. So consider the equation here, 3 is equal to log base 6 of x. We want to turn this around. So if we look up at our equation here, the 3 is taking place of the y. The b here we recognize as 6, and the x is just the x there. So we would turn this around and write it as x equals b, which in this case is 6, raised to the y power, which in this case is 3. So we do just that. X equals 6, the base, raised to the other number, which in this case is 3. And then x equals 6 to the third, that's something we can actually work out. What does x have to be? 6 to the third is 216. As another example, consider the equation here. 5.4 equals log of x plus 3. Now since we're not using any subscripts here, we know that that is actually log base 10. So here, as we look at our problem, the 5.4 is again taking the place of y. The base isn't written down, so we know it's 10. And then the x is being replaced by x plus 3. So we again go in and put that into our exponential format. Doing so would give us x plus 3, the stuff inside the log comes out, equals the base, which is 10, raised to the other number, which in this case is 5.4. Now we can go ahead if we want on a calculator and type in 10 to the 5.4. I'm going to hold off on that for a moment until I have x completely by itself. So that means to get x completely by itself, I need to bring that 3 over to the other side by subtracting. And then I can just go into a calculator and type out 10 raised to the 5.4 minus 3. And when we do that, we get an answer of 251,185.64. 251,185.64. And so now we have our result. And if you took that answer and plugged it back in, log of that plus 3, you should get roughly 5.4. Again, we did some rounding, so it's going to be off just a little bit. Now we want to go the other way, which is we're going to be given an equation that's written originally in its exponential format, and we're going to use this relationship to transform it back into a log format where we'll actually then be able to solve the problem. So consider our first equation, 10 to the x equals 250. And in this format, I'm really not able to solve it. But if we go back here and say, hey, there it is, 10 to the x. So this time x is actually taking the place of y, and the 250 is taking the place of the x. So we turn around and put it in the log. Since the base is 10, we're going to use the common log. So we would write that down as my exponent, which is the y in the formula up above here. All right, so it's going to come out y equals, or in this case, x equals. And then it's 10 is the base, so that we'll use the common log of 250. And because it's common log, we can turn around and plug that into a calculator and get an answer. Log of 250 is 2.398. So if we now turn around and raise 10 to the 2.398, we're going to get roughly 250. We're going to be a little bit off because we round it, but it'll be pretty close. Consider this equation. E to the 2x plus 1 equals 15. Okay, so here the base is e. So we're again starting with the exponential format. E to the 2x plus 1, so the 2x plus 1 is taking the place of the y, and the 15 is taking the place of the x. And then we're going to turn it around, and we're going to write it as y equals log base b of x. So 2x plus 1 is equal to log base e, which is our natural log, of the other part, which is 15. Now we can again go straight into a calculator and do ln of 15, but I'm going to hold off until the end to do that. So to solve for x, I need to get it by itself, so I bring the 1 over. Now I wrote that as minus 1 plus ln of 15. You could have written it as ln of 15 minus 1. Just make sure that with the ln on your calculator, you usually have grouping symbols. Make sure it's ln parentheses 15 minus 1. I just chose to write it this way. And then we just have to divide by 2. So we get negative 1 plus ln of 15 over 2. That's my exact answer, and sometimes in the homework they'll ask you for the exact answer. And then we can just plug that into a calculator. To get our answer. In this case, 0.854. So if we were to take that answer and turn it around, 0.854, put it in for x, we would get roughly 15. Again, we rounded off a little bit, so it's not going to be exact, but it should be pretty close.